So in the previous video, we looked at the cosine rule, and in this video, we're going to be looking at the sine rule. And so the cosine rule was used when we knew two lengths with an angle in between, so we can find the third length, or when we had all three lengths and we wanted to find the angle. Now a sine rule is used when we have just two angles and a length, or two lengths and an angle, and we're trying to find the next one. So if I was to just draw it out, let's say we have a triangle, which looks like this. These angles are capital A, capital B, and capital C, with lengths A, B, C opposite these angles. Okay. And the sine rule states that sine A over small a is equal to sine B over small b, which is equal to sine C over small c. You might also see it upside down like this or reversed like this, but it's just essentially the same thing. So you just need to be aware that they might just write it like this as well, but it's the same equation. Okay. So as I said before, the sine rule is used when we know two angles and a length and we want to find the next length. Or we know two lengths and an angle and we want to find the next angle. Okay, so that's when the sine rule is used. Alright, so let's take a look at this question here. So we're asked to find the angle x and the length y. So we need to find a couple of other angles and lengths first in order to do this. So first things first, if this angle is 145, then this is 180 minus 145, right? So which will give us 35 degrees. So therefore, the triangle to find x is 180 minus 35 minus 60 degrees, which will give us 85 degrees. That's the angle x. Right, in order to find length y, we need to think of the pairs, right? So we know this 8 length here and the angles, that's one pair. We know this angle x, so we need to find y, so we can use the sine rule. So we can say sine 85 divided by the opposite at length, which would be y, is equal to sine 35 opposite the length, which would be 8, which I can rearrange to get y is equal to 8 sine 85 over sine 35 degrees like this, which will give me 13.9 centimeters. So as long as you use the correct pairing, so the correct angle and the opposite lengths, and then you plug into sine rule, then we get the answer here. Let's try another one here, okay? So we know 72 degrees, so that pair of 72 is this y centimeter. The pair for 56.4 is x centimeters. We know this length here, so that pairing angle will be this angle here. Let's call it A. Okay. So therefore, we need to find this A first in order to use this 5.9. Otherwise, we can't use this 5.9, right? Luckily, it's a triangle. So A is going to be 180 minus 72 minus 56.4 degrees, which will give me 51.6 degrees. Right, now I can use the sine rule. So let's just find y first, right? So we can say that sine 51.6 and its pairing at length is 5.9 is equal to sine 72, but that's the opposite one of y, over y, which I can once again rearrange for y. So y is 5.9 sine 72 over sine 51.6 degrees, which will give me 7.11. To find x, we need to use the 56.4 degrees because those are the pairs, right? So we can say sine 56.4 degrees over x is equal to, now you can use either one. You can use the pair of 72 and y, or you can use the pair of a and 5.9, okay? It doesn't matter which one you use, you'll get the same answer. So I'm going to use the a and 5.9. So sine a was 51.6 over 5.9, which I can rearrange for x. 5.9 sine 56.4 divided by sine 51.6, which I can plug into the calculator and get me my x value, which is 6.23. So as long as you're consistent with the pairing used, so you just use the right angle with the appropriate opposite side, then you can just plug it into the sine rule and find all these angles or lengths.